Good afternoon, students. Rushti sir back with a new question. Actually, this is a sequel to my last lecture, important rolling body problem. Are you aware of my credentials? I think yes. Okay, let's go to the sequel of my previous lecture, that is PDL 108. I uploaded uploaded a video lecture on the that is the pulley rolling down the string in vertical direction, and one more block is supported at this point by a string also. But now I am discussing this block was the block of mass M2 was hanging earlier from through a help of a winding string wound around this in clockwise manner, okay, and hanging below. That time we proven that the string will become loose. Now I don't have that type of arrangement. I am fixing that block M2 resultly to this point B, opposite to point A. O, C are in same line. O is the center of the disk, C is the center of mass of the disk and M2. Disk mass is M1, radius R. This is the inextensible string, massless string wound around the disk. So the pulley, which is a uniform disk of mass M1, radius R, is suspended from the rigid roof with the help of a massless inextensible string wrapped around the disk. A point object of mass M2 is rigidly attached as the point B. A is the point where the string is tangential to the disk, as you can see here. AZ, Z means into the plane, I call this AZ. AZ is the line which is the instantaneous axis of rotation. That means is a line through the point A perpendicular to the plane, which is the instantaneous axis of rotation. As the string is inextensible, the string, none of the vertical part of the string has any velocity. It is an inextensible string. So AZ will be the axis of rotation for the disk. AZ is the line into the plane of this diagram passing through A. A is the touching point. Okay, what is the question? Now the system is released. At the instant of release, find the string tension and the acceleration of the disk. That's it. स्ट्रिंग में टेंशन क्या होगा और डिस्क का एक्सीलरेशन क्या होगा, बड़ा सा डायग्राम लेके बनाया मैंने डिस्क को. A is the point having zero velocity. As you know, string is inextensible. That is zero velocity with respect to ground. Is attached to roof. Roof is same as ground. AZ is the instant axis of rotation. Z is into the plane. Perpendicular to the plane is the Z direction. This figure 2. R is the radius of the disk. C is the center of mass of the system of pulley and the point block. O is the center of mass of the disk. So these are the three-body diagram. It is M1G acting at O, M2G acting on the block M2 at point B, tension acting here upward. So from the laws of motion, what can I write? M1G plus M2G minus T, the net force downward direction. That must be total mass M1 plus M2 into acceleration of the center of mass is AC. Okay, equation 1. Taking torque along the AZ axis. People say torque about A, but that more appropriate will be component of torque along AZ line will be M1G into small r clockwise, M2G into 2r clockwise, and no tension by T because that is passes through the point A. So that must be equal to, because this is axis of rotation case, so IAZ into alpha. Alpha is the angular acceleration, okay, of the disk. That is pulley also same as the disk. Okay, so M1 plus 2M2 GR, rearranging properly, IAZ will be 3 by 2 M1R square. For the disk about this point, it will be half mr square plus mr square, 3 by 2 mr square plus m2 contribution will be m2 into 2r whole square. Okay, so that is to IAZ will be 3 by 2 m1 plus 4 m2 r square. R is the radius. R is the radius of the disk. So एक R cancel कर दो. So okay, then in this equation IAZ I calculated. So replace the value of IZ here in this equation. M1 plus 2M2 G into R is equal to IAZ into alpha. एक R cancel कर दो. Alpha ये रह जाएगा M1 plus 2M2 G is equal to 3 by 2 M1 plus 4 M2 into R alpha. Okay, equation 2 को याद करो. So what is the acceleration of center of mass? Since this is axis of rotation, it is easy for me to find the acceleration of center of mass. That is the RC into alpha. Alpha into RC will be AC downward. Alpha clockwise into RC will be AC downward because AZ is the axis of rotation at this instant. So at this instant, AC will be RC alpha. Equation 3. भाई RC तो निकालो. RC very easily आप can निकाल सकते हो. RC जो है the position of center of mass from A, that is R into M1 plus 2R into M2 divided by M1 plus M2, as you must be knowing by now. Okay, that is M1 plus 2M2 by M1 plus M2 into small r is the RC. तो ये RC के वैल्यू इधर इक्वेशन 3 में लगाने से AC will be M1 plus 2M2 divided by M1 plus M2 R into alpha. ओके, ये AC है. बट R अल्फा का वैल्यू मैं पहले इक्वेशन 2 से निकाल सकता हूँ. M1 plus 2M2 G by 3 by 2 M1 plus 4 M2, ये R अल्फा वैल्यू उधर लगा देंगे. तो substitute value of R alpha for equation 2, I get AC is equal to this term M1 plus 2M2 by M1 plus M2 and R alpha term from equation 2 M1 plus 2M2 G by 3 by 2 M1 plus 4 M2. So that gives you 2 into M1 plus 2M2 whole square G divided by M1 plus M2 into 3 M1 plus 8 M2. ठीक है, जो भी ये आया अब देख लो, आप खुद भी कर सकते हो उसको और मेरे साथ चेक भी कर सकते हो. ये इक्वेशन 5 AC आ गया. तो इक्वेशन 1 में मैंने क्या लिखा? M1 plus M2G minus T is M1 plus M2 into AC. AC हमें निकाला इक्वेशन 5 में, उसको सब्स्टिट्यूट करेंगे. सो वही मैं बोल रहा हूँ. तो substituting value of AC in equation 1, M1 plus M2G minus T is M1 plus M2 into AC is this. एक ये आपका कट जाएगा इससे. सो T will be M1 plus M2G, M1 M2 M1 M2 कैंसिल हो जाएगा. It becomes 2 M1 plus 2 M2 whole square G by 3 M1 plus 8 M2. ये हो जाएगा T. इसको सब्ट्रैक्ट करो, G कॉमन ले लो. सब्ट्रैक्ट करने से ये आएगा M1 plus M2 into 3 M1 plus 8 M2 minus this divided by 3 M1 plus 8 M2. That will give you M1 square plus 3 M1 M2 by 3 M1 plus 8 M2 G. और M1G कॉमन ले लो. दैट विल बी M1 plus 3M2 by 3M1 plus 8M2. ये इक्वेशन 6 है. ये T का वैल्यू. केसेस देखेंगे. अगर M2 कुछ नहीं है, 0 है, तो आज एक्सपेक्टेड आवर प्रीवियस लेक्चर जो भी टेंशन था स्ट्रिंग में M1G by T वही आ जाएगा. आज वी फाउंड लास्ट वीडियो VDL 108. केस 2 में क्या है? केस 2 में क्या है? If M2 is quite large compared to M1, then उसका भी हम लिमिट ले लेंगे. तो T का ही वैल्यू है ना, उसको M2 को डिवाइड कर दो. M1G into M1 by M2 plus 3 divided by 3 M1 by M2 plus 8 ये आ जाएगा. बट M2 क्वाइट लार्ज है, ये बहुत स्मॉल है, ये बहुत स्मॉल है. सो 3/8 लिमिट रहेगा. तो दैट इज 3/8 M1G. ये अगर M2 बहुत बड़ा है M1 से. ठीक है, वो तो टेंशन आ गया. फर्स्ट क्वेश्चन था और ये एक्सेलरेशन पूछ रहा है डिस्क का. डिस्क का मतलब डिस्क सेंटर का, ओ का. AO will be R alpha, as you can see. What is AO? R into alpha. What is AC? RC into alpha. These are used already. So AO will be R alpha. So आपको आर अल्फा वैल्यू तो हमको इक्वेशन 2 में मिल चुका है, जो कि हम यूज भी कर चुके। आर अल्फा वैल्यू क्या है? m1 प्लस 2m2 g बाई डिवाइडेड बाई 3/2 m1 प्लस 4m2, बस। ठीक है, ये इक्वेशन 2 से मिल गया आपका आर अल्फा वैल्यू। ये है आपका ए नॉट ए ओ। सो केस 1 में सिमिलरली अगर m2 0 है as expected, it will be 2/3g। इसको 0 कर दो, m1 कैंसिल कर दो, सो 2/3g होगा ए नॉट, as observed in my previous video BDL 108। ओके, प्रीवियस वीडियो में क्या है, जो स्ट्रिंग में हैंग कर रहा है m2, सो टेंशन इज 0, m2 का कोई इफेक्ट नहीं है, तो m2 को 0 का बराबर ले लिया। बट अभी अटैच किया m2 का वैल्यू अगर बहुत बड़ा है m1 से, m2 इज मच ग्रेटर देन m1, तो उसका भी ले लो आप लिमिट m1 by m2 plus 2 into divided by 3/2 m1 plus m2 plus 4 into g, and this is quite this is negligible, so 2/4g, that means g by 2. So a naught limiting will become g by 2 if AO, center of the disk, will have acceleration g by 2 if m2 is much greater than a. So how this graph will be looking like? अगर m2 by m1 रेशियो 0 है, m2 0 है, तो g by टेंशन होगा mg by 3, then slowly it will increase to 3/8 mg। just see this, m2 much greater है तो m2 by m1 very large, so almost infinite, it will be 3/8 m1g। for m2 is 0, it is m1g by 3। so this graph is showing that t by m1 the y-axis, m2 by m1 x-axis, so the value will be at m2 by m1 0 है तो 1/3 है, m2 by m1 very large infinite है तो इनका 3/8 होगा, 3 by m1 will be t by m1 will be 3/8, ये m2 much larger than m1। सिमिलरली इसको भी आप प्लॉट कर सकते हो, एक्सीलरेशन by g in y-axis, m2 by m1 in x-axis। तो when m2 by m1 m2 0 है, m2 by m1 0 है तो 2g by 3 a naught, ये 2g by 3 means a naught by 2/3, and finally it will approach half, a naught by g will be half, with m2 goes on increasing very large compared to m1, it approach half। so this is asymptotically increasing tension as m2 increases, and this is asymptotically decreasing to the acceleration decreasing to g by 2 as m2 increases. This is the graph I have shown. So again, I am referring back to my previous video lecture VDL 108. If the block m2 hangs in a string from B, not rigidly attached, then string becomes loose and the tension becomes 0 in that m2 block. So m2 falls freely with acceleration g back. The pulley becomes isolated from the m2 because that tension in the string supporting the block m2 is 0. So they are as good as not present for as far as the motion of the pulley is concerned. Okay, so this is very interesting one, and especially the limiting cases. But these expressions AC, A naught, tension, I have derived it general manner. So this is what I wanted to discuss, this type of cases, this pulley rolling down a vertical string type of question, which sometimes people face difficulty. And this, as I told you, some of you are sending the requirements. So I am framing the questions so that the doubts in your mind will get clarified and you get enough benefit in your coming days. Okay, so don't feel hesitant to ask me any question, and you raise your doubts and you raise your requirements. Pushti sir will be there with the examples to satisfy your your doubts, to satisfy your or to clarify your doubts and satisfy your requirement. Okay, so this much for today. Thank you all. Very soon I'll be coming with an extremely important new topic. Thank you all. Come to my channel regularly. Subscribe if you have not yet, so that you'll get notification the moment I upload anything. Okay, thank you all. All the best to you.